Good morning, good evening, good afternoon, everyone. My name is Frédéric Desviens, and I'm the product or program manager
Good afternoon,
for
everyone.
Edge and
My name
IoT
is
at the
Frédéric Dupin,
at
and
the
I'm
Eclipse
the
Foundation.
product program manager. Good afternoon,
For
everyone.
Edge and
My
IoT
name is
at
Frédéric Dupin,
at
and I'm
the Eclipse
the
Foundation.
product program manager. Good afternoon, everyone.
Edge and
My
IoT
name is Frédéric Dupin,
at
and I'm
the Eclipse Foundation.
the product program manager.
Treasurer, sorry to interrupt, please mute. Treasurer, sorry to interrupt, please mute. Treasurer, sorry to interrupt, please mute.
Okay, so I've got confirmation I don't hear myself, but it seems I'm heard. So apologies for the technical difficulties. So once again, welcome to this virtual IoT meetup. It wouldn't be a real meetup if we didn't have such nice difficulties. But anyway, I'm Frédéric Desviens, the program manager for IoT and edge computing at the Eclipse Foundation. And it is my pleasure to welcome every one of you to this broadcast. Before we get to the main event, our speaker, there are a few things I'd like to highlight. First, we'll be having an Eclipse IoT Day in the flesh this coming May 13 in Santa Clara, California. So the IoT Day is co-located with the IoT World 2019 conference. Please, it's still time to register if you haven't already. I will be there, and we'll have a very interesting stable of speakers to give you content about various aspects of IoT. And today's speaker, Farah, will be speaking at the IoT Day as well. So if you want to see her in the flesh or maybe drop by her booth and see a live demo, then you are more than welcome to do that. Roughly at the same time in Europe, there will be the Bosch Connected World Conference as well. Bosch Connected World is a very, very important event for IoT in Europe. And the Eclipse Foundation will have its own booth there and will be presenting various innovations that we've been working on with Bosch and other partners as well. So once again, there's still time to register there if you want to attend. I'd like also to highlight that our speaker, Farah, is essentially has been elected recently on the Eclipse Foundation Board of Directors. So thank you so much, Farah, for being a candidate and joining us in trying to make IoT a better place, and the Eclipse Foundation a better place as well. It is not my pleasure to introduce our speaker for today. So Farah Papaioannou, sorry about the last name. So Farah is the co-founder of Edgeworx and president of Edgeworx currently. And she'll be telling us about innovations in edge computing. So up to you, Farah.
Thank you, Frederick. Appreciate it. Let me share my slides here. Oh. Oops, that didn't work out very well, did it?
No worries there. I did that the last time and the audience really enjoyed it. So no worries.
I seem to be having some technical difficulties here because I have my slides open, but the share is not allowing me to share them anymore. Just give me 1 sec. Try something else here.
So it seems we lost our presenter. So while we are waiting, let me share with you something about our most recent developer survey. Oh, just opening the right set of slides to do that. So this is something I presented at the Eclipse IoT Working Group call yesterday, and you'll be the first after them to have a look at this. So, all right, let me share my screen while Farah is coming back.
Frederick, Farah is now there.
Ah, she's there? Okay, all right. So we'll keep that for the end then.
It's okay, Frederick. You keep on going. I'm still having difficulty getting the slides up, so I'll let you know when I'm up and running, okay?
All right, no problem. Okay, so let me share my screen again. Oh gosh. And it seems my Hangout is about to crash as well.
It's okay. I have success, I think.
Okay, fantastic. So please take the lead, and I will restart this.
Fantastic. Can you guys see my slides?
Yes, we can.
Great. Well, thanks everyone. Sorry for the technical difficulties, but it wouldn't really be a virtual meetup if there wasn't one. So let's just jump into it today. Today I'm going to be exploring the trend towards edge computing, and who knows, maybe this is a use case that edge can solve in the future. I certainly hope so. So thanks for the introduction, Frederick. I'm going to spend a little bit more time digging into my background just a little bit, so you have some idea as to who I am and why I'm here talking about edge computing. I'm currently the co-founder and president of a company called Edgeworx, and we've actually open sourced the technology that we built, Eclipse IoFog, which is now known as Eclipse IoFog, into the Eclipse Foundation. And we're really excited about the technology and what it's trying to do. It's focusing on the market of edge computing, and what we've built is actually a universal edge computing platform. So that's why I'm here, and that's why I know just a tiny bit about the edge. My background has largely been in enterprise software and storage. I was a student at Stanford studying UI and UX, and I was actually supposed to do my first internship or my first job at IBM Labs, and the recruiter sent me to the wrong address, and I ended up at Hitachi Data Systems. So being 19, I walked up to the front desk and said, "Hey, I have an interview," and the Japanese are incredibly polite, so they threw one together for me. And at the end of an hour, I was hired on the spot, which was great, except for the first couple of weeks I didn't actually get paid because no one was expecting me to be there. And that's how I started my career into enterprise software and storage, and I ended up staying there for 7 years. Then moved to HP, where I moved out of more of the engineering roles and into M&A, and realized quickly there that in big companies there's very little innovation. In fact, what HP and everybody else do is they typically acquire from more smarter people who are working at small companies and have the ability to.
Sorry to interrupt, Farah, but your slides went black, so we cannot see anything.
Oh, that's a problem.
There we go. Now we can see, but when you go into presentation mode, they go black.
Okay, well, thanks for the heads up. Let's see if we can't just get them into close enough. There we go. Can you see the full slide?
Yes,
we can.
Yes, we can.
Okay, great. And there we go. Cut my teeth at HP, and from there, moved into venture capital. So I spent the better part of a decade as a VC, and this is kind of how I got to edge computing. Spent time looking at, again, started at storage, then big data, then that got me to machine learning and artificial intelligence, and then that led me to this idea of edge computing, because what I realized was that all of the data that was being generated, all the growth of data was coming out from outside of cloud and data center. If you think about the amount of data your phone generates, take that and now multiply it to all of the devices in the world, because now our cars have compute and oil pumps have compute, and pretty much any device you can think of is going to have some sort of compute in it. And the notion that all of that data could be sent back to some sort of cloud or data center just seemed illogical. That was not going to happen for reasons of bandwidth, latency, cost, even time to respond. I mean, if you think about autonomous vehicles is going to be a thing. If you think about, if I were to send all the data back to a, cloud to do some processing and then send some result back to a car, some, life or death things could really happen. So that's kind of how I got started through edge computing. So, I personally believe that edge is going to be the big trend for the next 20 years, the same way cloud has. But the edge is a really different beast, and I think we're going to spend a little bit of time digging into why. So we all have know about cloud and data centers. There's we've come to rely on high-speed connectivity. Well, at the edge, what you often find is very limited or sporadic connectivity or mixed connectivity. You can be on Wi-Fi 1 minute and over cellular the next. And, this is really an example of what a customer environment would look like. Connectivity is not, really robust, and it's hard to get, imagine all that data transfer coming from something like that. From a compute standpoint, cloud is homogenized and virtualized. Compute largely looks the same. versus the edge, which is very heterogeneous and targeted. To the edge can mean different things to different people. It could be an oil pump, it could be a car, it could be a micro data center. And developing software for these different types of devices. You have to think about: am I running on x86? Am I running on ARM? Am I running on a GPU? And trying to develop software for these different types of environments and running it there is a very difficult challenge. And then security. In the cloud, we've come to rely on physical security. Only limited and authorized people have access to the cloud. Versus at the edge, things are literally out in the real world, and anyone can access them, and you have to almost assume that they will. My co-founder likes to tell a great story from his time as IoT advisor to the city of San Francisco, and he does a better job, but I'm going to butcher it and tell it because there's real good value to be had from it. Somebody actually took a CAN bus adapter off of a CAN bus box, off of an SF Muni bus, literally took a screwdriver and took it off. And on it had the private key information and VPN, which would have been fine in the cloud or data center, but was definitely not in the edge. And so this guy walked into the back of the city's infrastructure, and who knows how long he was there before he decided to shut down the SF Muni terminals and ask for a Bitcoin ransom. And, the city was scrambling to, fix all the keys and get the infrastructure back up and running. In the meantime, another hacker, maybe he was a disgruntled commuter, hacked into the guy's email address and told him next time pick a different city, and then hacked him out of his email. So there's a happy ending to the story, but the lesson to be had was that we can't think about security in the exact same way, and we have to assume that things are going to be compromised. And so the question is, if that's the case, how do you keep that from propagating across into the cloud and data center? And then power, we have come to, expect a optimized, power efficient cloud or data center. But at the edge, what we see is things that are running on battery or low power wireless. Here's an example of something running on actually solar. And so, we have to think about things differently. And so that's something we have to manage and really think about when we run software at the edge. But despite the challenges, I do think edge is big. So I personally believe we're going through a transformation, and we go through these periodically. Before we were, it was all about the mainframe and compute was centralized. And then, because of the, accessibility of hardware and cost, and because of the things we can do, we shifted over towards, a client server architecture. So we moved to more of a decentralized type of compute. And then, we realized, we didn't want it to be optimized. So we came back to the cloud and we centralized everything yet again. And now I believe we are on the process of decentralizing back out to the edge. And so, the 20-year transformations we go through, we're about, I think, at the start of this. And so over the next 20 years, you're going to start seeing, the edge become part of the people's infrastructure, where we'll see data center, cloud, and edge. And for the people who don't catch on, then they're going to, miss the boat and end up becoming a dinosaur that, isn't on the front cutting edge of things. Like I said, I spent some time at HP. They really missed the boat on cloud, and now they're, never going to catch up to the likes of Amazon. So I believe that this is going to, the same sort of transformation is going to be happening at the edge, and we're very fortunate that we're at the start of it and we've caught it early. So I mentioned earlier that the edge market was big, right? And here's some stats as to why I think so. I talked about the number of devices. By 2025, it is projected that there will be 50 billion with a B, smart, quote unquote smart devices, devices that generate data or have some sort of connectivity. We're going to see 163 zettabytes of data. Can you imagine sending all of that back to a cloud? That's just not going to happen, right? I actually think the stat is low, but I'm being conservative in terms of the size of the market. So there's a lot of opportunity to be had here, and we're starting to see a lot of players kind of come into this market. The edge market is starting to really fill up with different types of technologies and companies. And the growth, I think, I think it's conservative, but there's going to be a ton of growth in this market, both from the amount of devices, the amount of data, and then obviously the money to be made in this market. So I know this is the IoT meetup, but I wanted to clarify that edge is not IoT. Not to say that IoT is bad or one or the other is better, but I think it's worth noting that they are different. And why is that the case? So when we think about the Internet of Things, we really focus on the things, the devices themselves, sensors, and how do we get that data out and into some sort of cloud to process data with. And where I think of the edge, I think the edge is a broader in terms of, where it plays. My thesis is there's a cloud edge continuum, and the edge thinks about the edge of the cloud or the network. The edge can be an on-prem data center. The edge can be a micro data center. The edge can be an IoT gateway, or the edge can actually be the things itself. So I think IoT is a use case that the edge can play in. And what we're seeing actually is there's an entire mix of environments where companies are going to take cloud plus maybe something running at the edge of the cloud plus some on-prem data center plus some micro data center plus some things as they get smarter and smarter, and market requires them to decentralize, and the edge sort of encapsulates that. And in order to be successful at the edge, you're going to have to be able to learn how to run software in all of those different environments, whereas the IoT you can really focus in on the devices and the sensors. And so that's sort of where I see the differences. And I think Eclipse sort of sees it the same way. In that now the Eclipse Foundation has created their own Eclipse Edge working group, because the market is seeing that these two things are different, and I think it does a disservice to IoT to kind of and the Edge to kind of mix the two. And why haven't we solved this problem yet today? The Edge is really difficult. And I kind of gave some insight into why when I talked about the differences between cloud and data center. We have started to see rollout of edge computing. It's not new to this idea of running software at the edge. I mean, I have cameras in my house, and we do object recognition, to see if if there's any intruders coming in, if my kids are running out when they shouldn't be, where our pets are. But it's very limited in scope, and all of that data goes back to the cloud, and there's obviously challenges with that. But there's no ability to do anything dynamic with that. It's that software that's out there, and it's fixed. And that brings me to my next point. What we are currently seeing is these very vertical siloed applications where we're solving very specific use cases. And can you imagine if that was the way it was in like cloud or data center, where I had a complete stack for my Gmail and an entirely new stack for Office? I mean, that just really wouldn't fly. What we have today is like this compute that enables us to run any sort of dynamic applications that we want. And these inflexible silos are very costly to deploy and to manage. And I think we're seeing the similar challenges in IoT as well. And existing software solutions that have started to poke around at the edge have again require this data to go back to cloud or data center. Not to pick on any one company, but Amazon and Microsoft have focused on IoT and edge computing, and they require all of that data to go back to their own cloud. And my own personal opinion is then you're really not solving the challenges of the edge if you're still having to send that back to the cloud. You're still going to see the problems of bandwidth, latency, cost, especially cost, and then problems with security. So what do we want? What developers want? Eclipse is a developer-focused foundation. We want platform stability. As I mentioned, what we've been getting is vertical silos. We've been getting redneck architecture where things are just pieced together, and we kind of cobble something together and we solve it, and then we want to make a change, and then now what? We cobble yet another piece, right? That's not what we want. We want a seamless developer experience. What we get is a homebrew computing cloud. I know, because my office often looks like this. So what do developers need? This is personally what I believe developers need. If this looks familiar to you, if you've been to my Edgeworx website, or you might have heard some of the same language and seen some of these same graphics. And I'm not here to sell you on why you should come to Edgeworx, or why IoFog is awesome. I personally believe it is. But these are the challenges that I believe are important, and these are the problems that we're trying to solve. And it just so happens I spend my life working on this stuff. But I want to kind of dig into the concepts of what we need to solve problems at the edge. So people should be able to what we believe is that people should be able to bring their own hardware and turn it into a compute platform. They should be able to take any device that they have, be able to run applications at the edge, right? So they, there shouldn't be required to use any piece of specific hardware or use any sort of specific developer tools. And then working with some customers, we've started to we've started to uncover some patterns that we're starting to see at the edge, where people want to see certain things. They want to see their devices be intelligent. They want to see things be connected. They want to see some management. They want to see some security. These are the things that are currently missing to make the edge easy to work with, rather. I mentioned earlier that one of the challenges at the edge is that, it's very difficult to write or deploy software. If you think about, deploying software to, an NVIDIA box, you can get there, but it's going to be very painful. And if you want to take that software and port it to something else, you're going to have to go through a lot of challenges. And it's not very easy to deploy these apps. So what we really want as a developer is the ability to run any software on any hardware. Wouldn't it be nice if I could write this piece of code once and I could deploy it on a cell tower? I could deploy it on a Wi-Fi router. I could deploy it at the edge of the cloud. I could deploy it in the cloud. I could deploy it in the car, wherever, right? That would be a really nice world, because a lot of the use cases that we see at the edge are, largely similar. We often see, object recognition code being used. We often see video data being taken in, and that video data being processed to sort of detect things that are of interest to us. So if you're in an oil and gas use case, you care about whether fire is broken out. So that's what we use object recognition for that. If you're, in a government, you care whether or not your border is being breached. Not to get into any discussion about walls here, but if you're, in a mining, you care about where your people are. So people have different uses for different things. But the code itself doesn't actually change. It's the hardware that's actually changing. So that's the thing that I think what we really need at the edge. We need to be able to remotely deploy and run applications. Right now, I mentioned that, we have the object recognition example at my house. Well, let's say I wanted to make that code smarter. Let's say it keeps catching, flies that fly past, or birds, and I don't really care if it notices those things. What I really care is if my cats have gone out, or if my kids have gone out, or if intruders are coming in. And if there's a way to train that model to do better, then I would like for it be able to dynamically update that software. Well, right now you can't actually do that. If you want to update that software, you literally have to wait for a new hardware upgrade to come out. So I have to wait for another camera to come out who might have better object recognition code. Or maybe, I've already started with object recognition code, maybe, something is running on the city and I can use it to detect people, and now I want to be able to detect license plates. Wouldn't it be great if I could just deploy that application now? Well, you can't actually do that today. And there are very rare instances where you have over-the-air firmware upgrades, but that's, few and far between. We literally have to wait for a hardware refresh or for someone to go out in a truck to add new software. But that's not obviously going to be a very scalable future. I already mentioned the idea of writing code once and running it anywhere, or even taking code that's been written for the cloud. Oftentimes these, problems have already been solved in cloud and data center. We just want the ability to deploy it closer to, where the data is generated, such that we don't have to send it back to the cloud and data center to have it processed. And then finally, if I was a developer, I want to be able to develop for the edge as easy as I could for the cloud. Why should I have to learn new tooling? Why should I have to learn a new framework? Why should I have to learn a new SDK? I should be able to take that, C# code I'm super proud of and still run it down, at the edge. I should be able to take Python, Ruby, Java, whatever it is, C++, and run it, because, the last thing I want to do is start to rewrite stuff. And if I do rewrite something or make it edge optimized, I don't want to have to rewrite it again and again. I'd rather focus on new problems. And so these are the patterns that we've started to see at the edge. I've spoken a little about the intelligence piece. The ability to take a device and turn it into a compute platform, I think is where we're starting at the edge. And I think that's sort of table stakes, the ability to run containers at the edge, and to be able to deploy the software. It's a hard problem, but I think we're starting to see that problem, getting solved. The next piece is management. So not only do I want to be able to deploy software at the edge, I want to be able to have control over where I deploy it. I'm not going to deploy all software equally. In certain environments, I want to deploy certain types of code, and I want to be able to manage my nodes and say, what's running on this? How do I update it? How do I say, perhaps the devices in this geography are going to run this type of code versus that type of code. Connectedness. And so I talked earlier about the one of the challenges that we face today at the edge is that people, sort of think well, if I take a device out there, add some connection, and then that data goes back to the cloud, my Amazon, that, I'm connected. And obviously those are limitations with that, but people don't necessarily want to just connect edge to cloud. Maybe they wanted to connect cloud down to the edge. Maybe they wanted to connect edge to edge. And I think we're starting to see a lot of that. Take the example of the vehicles. The vehicles need to be able to connect with each other. They don't want to necessarily connect to the cloud and then have that cloud connection to come back down. And so, the ability to connect devices is an incredibly important thing. And, not to plug IOFOG or anything, but it is something that we've actually solved for, to be able to create these encrypted peer-to-peer connections, just to kind of educate people on what's out there. I know there's a lot of interesting technologies in the Eclipse Foundation. Obviously, we're very proud of this one. And, this is a problem that is very difficult and that we solved. And then finally, security. Security can't be an afterthought, as we mentioned in that Canvas thing. Example, we have to think about security from day one. And, again, this is something that we actually have solved here, or continuing to solve. But, we have to be able to know where our software is running. We have to make sure the hardware is secure. We have to be able to know if the right software is running on top of the right hardware. And, wouldn't it be great if we could use all of the nodes in the network to be able to sniff out a bad actor? And that's the one of the things that IOFOG actually solves for. So, I mentioned, that the edge is everywhere, and we're starting to see certain use cases. And, it's always great to hear about things in theory, but it's always better to see how they're being used in practice. So I'm going to go through some examples of, where we're seeing, edge use cases come about. So one is in the example of a telco. So in this example, a telco has a number of Wi-Fi routers out into their customers' homes. And what they want to be able to do is a number of use cases, right? Can you imagine if they could dynamically deploy software on top of their Wi-Fi routers? There's a number of things that they could do. For example, they could take the data within the home of how performance is, and be able to identify, what are the challenges in terms of connectivity. No one's ever happy with their Wi-Fi router. Wouldn't it be great if the router itself could diagnose the issues and say, oh, you know what? There are too many connections on this network. That's why you're having issues. Or maybe it's not placed in the most appropriate spot. That's why you're having issues. So that's one thing that they, that they're looking at doing. Another is, one of the things that they care about is during, big sporting events like World Cup soccer, rugby, during the Super Bowl. People want to have good streaming quality. Not everyone gets their content off of TVs anymore. They often use streaming to get the content that they want. And so maybe during these important times, they want to be able to say, you know what, I'm going to throttle the bandwidth on things that aren't important, like, my kid watching YouTube or downloads, but really focus on the streaming quality of these sporting events. And so they now have the ability to dynamically deploy those software onto these Wi-Fi routers, and the sky's the limit, right? They could, even enable content providers to deploy software onto these devices. And so this is obviously great, because if they were to take that data and send it back to their own back end, it would further degrade performance, which customers obviously wouldn't be very happy about. And then they would actually end up having to house all that data and process it on their cloud, and that can actually do that on their Wi-Fi routers itself. So they've really expanded their own infrastructure. Another example is, in retail, right? The ability to determine, customer profiles, what customers like to buy, how often they're traffic through stores, and as those things happen, they can dynamically deploy, different applications down to the edge. One customer in particular is thinking about, well, if traffic is slow, perhaps, if there are people in the nearby area, we can send offers to them to say, for a short time, there's 50% off, at this restaurant. You can get, happy hour for drinks, and kind of drive traffic that way to these different retail locations. We're seeing examples in smart cities. And, I mentioned earlier about, border control. We're seeing, border control. We're starting to see things of public safety, the ability to use cameras at the edge to detect, is there a natural disaster? Is there, where are the victims? Where are my first responders? Again, object recognition code is, a very common use case that we're seeing at the edge. And in this case, they can deploy software on the, cell tower. They can deploy the software on the cameras themselves. They can, process the data on the cameras. And, to take an example from this one, what they want to be able to do is, do object recognition detection on the cameras. And then, have a dynamic applications platform onto their Wi-Fi router itself, so they can, let's say they're trying to detect persons of interest, right? And so they say, these are the people I'm looking for. And, it turns out that Frederick is at the corner of, First and Main, and, they can 99% of that video data is not necessarily valuable to them, but when they do detect their object, which is Frederick, wouldn't it be great if they could just process that data right there on the camera itself and just say, okay, well, Frederick's location is, here's the GPS coordinates, and here's the timestamp, and here's an image of what he looks like, and we can send that data back versus capturing gobs and gobs of video data, right? Instead of sending gigabytes worth of data from the camera, we can send just megabytes of data saying, here are the things we saw. So in this use case, rather than running like a dozen cameras, right now we can run hundreds or even thousands of cameras, because you can process that data right there on the camera itself. Send that data to the hub, like a cell tower, and in this case, the customer is using a mobile cell tower, so they can kind of deploy them wherever they want, and then process that data there. And then maybe if they want some to do some historical data analysis or whatnot, they can send a portion of that back to the cloud if they're interested in doing that. So, but they can now time it at a point where it's useful, or it's cost effective. They can maybe do it once a day rather than constantly hitting that cloud pipe, which is really expensive. And then, finally, here's another customer who's looking at the gym of the future. This is an example in hospitality, and what they're trying to do is, sort of say, like, I want to create these customer profiles. I want to know how often Jamika comes to use my, exercise bike. I want to know how much time she spends on it. I want to know where she's like constantly, in the gym, so I can, if I know she wants to, she's a bike person, she doesn't used to use the treadmill. I can maybe add more bikes if that's being used. I can, incentivize her to come at certain times when there's, more bikes available. I can gamify this for her. I can make it, I can start to create a profile of what this person does. I can create a profile of them outside. So, do this person exercise, when they're outside of the gym? What kind of, what is their sleeping patterns like? How can I create this holistic idea of this holistic person to offer them a better experience? And ultimately, the Edge enables us to touch customers better, so we can offer them a better customer experience, offer them more of what they need, rather than try and just generalize across out. And we can tailor things to individuals' needs. And so, on the more interesting side of things, that's what they're trying to look at. How can I create a VIP experience for Jamika? Oh, and maybe, today she hit a really great target. I'm going to reward her with, a free smoothie at the juice bar. And, now she wants to come back and use that bike some more because, there's incentives here. And on the maybe less interesting side, but still, for me anyway, but still applicable, these exercise bikes are already running software. And, the way we actually got introduced into this example is that they wanted to be able to update their software. And so taking one gym as an example, they had 200,000 pieces of exercise equipment that they needed to upgrade. Well, the only way that they could think to do so was to take somebody out there with a USB drive and hit each and every one of these 200,000 pieces of equipment. And, obviously that's not a really scalable model. So, with, edge computing, we can update that software over the air dynamically, right? And that's obviously super attractive. So that's an example of, kind of broadly, but I thought it would be kind of fun to dig into one example and to, kind of get a sense of like how we start off with one application and then expand into others, right? Other use cases. So this is an example in one of our oil and gas verticals. Not that that's the only thing we focus on, but it's an interesting one because there's a lot we can do to make employee experience better and enable safety in an environment that's often very dangerous. So this customer wanted to start off with fire detection. Fires are a real hazard for drilling in oil and gas. It's very damaging to the equipment and really costly when it's shut down. And also these oil companies have to pay huge fines if they break out in a fire, right? And we've seen the movies, Deepwater Horizon and et cetera, right? That's not where they want to end up. And so what they wanted to do is, this is how they started out with us, is they wanted to run machine learning algorithms on smart cameras to proactively identify fires and smoke in remote environments. Wouldn't it be great if we have cameras out oftentimes these oil rigs are in these very remote areas. In this case, this is an offshore oil rig, so it's not very easy to get to. And we can have cameras out there, detecting whether or not there's smoke, whether or not there's, things that causes concern. Are we seeing sparks? Before this breaks out into a fire, let's see if we can't, predictively try and fix this. Or if it does break out into a fire, then we know immediately rather than waiting for it to, spread and cause even more damage. We can do emissions monitoring. If that hardware is already out there, maybe we can take that now and identify harmful gas emissions and reduce workplace hazards and improve safety. So now we can add sensors and video data and analyze. So we already have that video camera out there. We can look for certain characteristics of gas emissions and analyze that data in real time on the camera itself. We can have like an IoT box on the or offshore oil rig. In this case, the customer is actually using their they had a mobile LTE network. And so not only are they providing like a private LTE connectivity to it, but now they're doubling that box and saying, well, you know what, I'm going to make that box that already has compute in it and make it an application platform. So we have all these video cameras running on the offshore oil rig. It's already detecting fires. Now let's add gas emissions, and that data can be reprocessed, near the pipe. And now we can send, aggregate that data like on the LTE box, right? Because that data is already parsing through it. And then they thought, well, we're already like using video data to detect where, whether a fire breaks out. We're also able to collect video data and see, are people like wearing their hard hats? Are they safety compliant, right? Do they have their goggles on and whatnot? Well, the cameras are already there. We've already deployed one application. Why not deploy another? Isn't it very simple to take that same video code and say, okay, I've model trained to detect for fires. Now I'm going to model train to detect for hard hat detection as well. And in fact, these guys not only detected it for hard hat detection, but they're also model training it to detect for people, because when fire breaks out or, they want to know where their people are so they can get them to safety as fast as possible. And so now they can do object recognition code to say, okay, here are where my people are at in my oil rig or in my refinery. So I can, identify where they are at all times and provide better safety to my employees. Pipeline monitoring. So, currently the way pipeline monitoring is done is via walkdowns. So humans come by, they look through the pipe, and then they leave. Now, what happens if it breaks the day after, like they've checked it out? Oh, well, we don't find out until they come back through for their next walkthrough. And that's literally how it happens. It's really hard to just take data from the, at the edge and then send that back, especially in these really remote environments. So now, like I said, we already have some of this equipment out there. We can now take this and run machine learning algorithms to be able to identify faults. Listen for noise level changes, right? If I can do object recognition code at the edge, I certainly can do natural language processing. I can take audio data, parse it out for detections and change in noises, detections and change in vibrations, and we can automatically shut it down so there's no issue and make an alert for an inspection rather than wait for someone to come back out and hopefully check it at the right time or wait for some big issue to happen before they actually shut it down. These seconds can count for a lot in these response times. And, when you think about it, I'm listening to these examples, I'm like, wow, they sound like these are no-brainers to me. Like, I can't believe this is actually happening. This is actually happening. This is in oil and gas. These are still what happens today. It's largely a human-driven environment, and we can do a lot with the data to make, safety be an issue for them. Forget even saving money, right? I mean, obviously there's some cost saving to be had here in being able to detect this and wait instead of waiting for some guy to walk out. But it's a lot, even when you think about safety, this is going to be huge for them. This is one on, obviously a cost savings for the companies, but offshore oil drilling is massively expensive to install, service, and replace. And, as I mentioned, what they literally do is send these people out periodically to check. We can do real-time collection of sensor information for machine learning and predictive inspection. So we can plan interventions of, one day when we need to take it down versus like unplanned shutdowns of 30 days or more, which can be incredibly costly, especially when you think about these are like billions of dollars worth of equipment. And thermal monitoring, we can not only like use video data, but we can use, sensors to detect if there are any, thermal fluctuations or a flaring event. And we can collect the data, analyze, and do some predictive AI to, check for any, fluctuations in heat that could potentially indicate a really costly or, dangerous event and reduce such shutdowns and get people to safety. So, these are just, an example of like when you get started, you can see why you wouldn't want to like take this examples. I think I went through about 6 of them and put out a specific, vertical use case for each one of these. What you like to be able to do is say, well, I've already started this. Now I can add that. Now I can add that. Now I can add that, do that. That's literally how software development works. That's how solutions are built, right? We start with one thing and say, well, now I can do this, and now I can do this, and now I can do this. Have this idea that we want to send out these costly silos to solve each one of these specific use cases is obviously not the way we develop software for the cloud, and not how we want to develop software for the edge. And so, this kind of gives you an idea of some of the things we're working on and where I see the trends in edge computing, and some examples of how they're being used today. And I think this is just going to expand. Some verticals are embracing this quicker than others, but pretty soon I think this is going to be the norm everywhere. And so, I'm excited to be a part of this early on and be jumping on this. Any questions for me? I know I kind of got through this maybe a touch faster, but I know I speak kind of quickly, so.
Yeah, so at this point, if anybody has questions, please write them in the chat for the YouTube broadcast, and I will pass them on to Farah. In the meantime, I have a question of my own, Farah. So,
please.
We talked a lot about software specifically in your presentation. But edge computing is also about a bit of hardware. You need a edge node somewhere to run your application in the field, right? So in your opinion, what would be the qualities of the characteristics to look for in a good edge node?
Yeah, that's a good example. That's a good question. So, I mean, our philosophy is that you should be able to use any compute that you're currently running on, and that you shouldn't necessarily need to put specific pieces of hardware out there. That being said, people do. And so I think the type of hardware that you look for depends on the type of applications that you want to run, right? And I think that's a similar kind of model of thinking as a cloud data center. So if I'm running like machine learning, to be honest, if I'm doing some compute intensive things like object recognition and machine learning, I often find that we want to have some sort of GPU enabled devices. The Jetsons are really good for use cases like that. If we're running things where I'm just collecting time series data, then we can just run on a low power box, some x86 box, or even lower. IoFog is capable on running on a Raspberry Pi or higher. And in some cases, a Raspberry Pi will do just fine. And so it doesn't. It oftentimes just depends on the use case. What we're starting to see though is customers are starting saying like, well, and this is kind of where the thesis kind of came out about focusing on the edge infrastructures. Well, my device already has compute in it, right? We're talking with automotive companies. Those guys already have compute in their vehicles, a lot of it actually. And so what we're trying to do is enable them to run using the compute that they currently have. Now, if their use cases demand it, then they're going to often, have to add additional types of processing. And in the case of the private LTE box, they were running some x86. They wanted to do obviously this crazy, object recognition stuff, which is pretty compute intensive. So they had to upgrade to a GPU powered device. And so, they just changed the processor out. And I hope that answers your question.
Yeah, absolutely. And so if I understand you well, essentially you pick the hardware according to the use case. And then with something like IoFog or even the commercial version that Edgeworx is offering, you can deploy on any type of node. Really, you don't really have to take into account the actual hardware it will run on that much.
Yes, exactly right. The hardware should match your use case. It shouldn't. That's all.
Absolutely.
That think about. Yep, and that's all people should think about. We're trying to mimic as much as you can with cloud and data center, and so you absolutely hit it right on the head, Frederick. Yep.
All right. And we have in the chat a question from Satish Rao. I hope I pronounced that correctly. So how do you see the role of blockchain in edge computing?
That's an interesting question. So we are using like blockchain inspired algorithms in the way we manage security. So the way security works for Edgeworx right now is that, or for IoFog, is that we use the nodes in the peer to dynamically detect whether or not there's an issue with one of the other nodes. Regarding blockchain question, blockchain technology offers a great way to create an auditable record of IoT and real world events. And edge computing provides a good approach to interfacing with blockchains, which may not move at the same speed as sensors. So I think there's some interesting applications for blockchain at the edge that people can can really dig into and explore. And I think we're just starting to really touch on those things. So I think there's a huge opportunity there to explore more into blockchains.
And that makes sense. And at the same time, I'm curious because I was having a conversation about blockchain with a colleague this morning, and how would I say that? I mean, a blockchain is essentially a distributed database, right? And since you cannot change records once they have been accepted in the database, then it provides, let's say, data security. So in that sense, it's an additional layer of security. But adding a blockchain implementation somewhere in your IoT architecture is not, in my opinion, a security measure per se, right? What do you think about this affirmation?
Sorry, can you just repeat the question?
So essentially, I'm arguing that just putting a distributed ledger or a blockchain somewhere in your IoT architecture is not in itself a security measure.
I would say no. I would say it's not in itself a security measure, but you can use the idea that you can have the edge as a distributed ledger in and of itself for transactions at the edge, and you can use it to verify all services and data that passes through. So, I think we leverage that edge that way, right?
Yeah, and that makes sense. So in that sense, blockchain is rather about data security or data integrity rather than pure security.
Yes, I think that's a great way to characterize it. You can leverage the edge as a way to audit or the transactions at the edge and of all data. So now you have some auditable trail of each place your data has gone through, right? By using the edge, you'll know exactly where the data has or has not been, and you can even get you can actually do this with Edgeworx, the Edgeworx version of IoFog, which is actually set policies around and say, you know what, I want my data to only not going in and out of these areas. So you can create zones and say, well, if I care about safety, then I want to make sure this data does not leave France. So I can create a virtual polygon around that data and say, look, this cannot leave this country. And now you can create an audit trail and say, you know what, I can demonstrate that this data does not, go in or out of this location. Same with the factory. And so, there's ways to, now use the edge to provide additional layers of security by thinking about, the data and services itself rather than the actual physical security.
Yeah, that makes sense. So given all the various government regulations that popped right and left to in order to regulate the storage and even the transit of data, then having a platform that gives you that kind of flexibility and that kind of geolocation constraints is something useful.
That's exactly right. Yep.
All right. We've got a few more questions in the chat now. So Harshit Chochan is asking, what about edge device security?
So the way we think about security, is, we like to be able to secure both the device itself and the microservices that run on top of the device. So what we've done is basically created a dynamic identity that takes all the different levels of hardware, from hardware root of trust, TPM, secure boot, binary attestation, BIOS and firmware attestation, and then microservices attestation to create a dynamic key. And so that's how we secure those devices. Additionally, we're able to detect whether or not there, certain policies are violated by monitoring, like the network traffic, such as, did someone, put a USB drive into the box and they weren't allowed to, or what type of microservices are running and did someone add a piece of code that they weren't allowed to, and that would actually quarantine the node and shut it down. I don't think you can ever say that something is not going to be hackable, because every time you do, you're just inviting someone to come in and hack it, and they will. What you can do is prevent that hack node from, propagating up the chain. The way I like to think about it is like my device. If I leave my device out in the world, my iPhone, it could potentially be hacked. I can't stop it, right? Because it's out there. The best thing I can do now is, lock it or wipe it remotely, right? And hope that all of that important data, which is like sitting in my iCloud account, doesn't get they don't get access to it, right? And so that's I think all we can do in terms of edge devices at this point.
That makes sense, and at the same time, and this is something we see in IOFOG, right? The way the networking is dynamically controlled by software. So network design is also a big part of how you can make your overall IoT architecture secure.
Yeah, exactly right.
All right. Another question now. From Alex Kritikos, what specific features are offered to facilitate offline first applications?
That's a good question. Can you provide a little bit more clarification as to what you mean by that?
That would be for Alex to say, but the way I understand these questions, some applications, let's say, well, if we take the use case of transit, for example, transit and specifically payment for transit, we could have an edge application that would, connect some kind of reader in the bus to the payment collection system, but maybe there will be gaps in connectivity. That means, well, you need to collect fares and then send whatever data you gathered when you come back online.
Gotcha.
So,
I understand the question now. Thank you. Thank you for the clarification. Okay, so in offline mode, if things didn't work in offline mode, then it really wouldn't be very helpful at the edge, right? If you had to assume that there was like strong connectivity, it wouldn't really be very good. Example at the edge, right? So, and in the case of these oil and gas stuff, satellite connections often go down, or they're only available like once a day. So we have the ability to process all this data in offline mode. That's what makes the edge so great. Because you have the box local now, and you can actually then, the ability to store and forward messages either to additional nodes in the network, which is why the example of the ECNs, the edge compute networks that I talked about with the connectivity is actually so useful, because if one box completely goes down, they can push forward that message to a nearby node. And then when the connectivity is up and available, then they can push that data back to the backend if that's what they wanted to do. Yeah,
and Alex clarified this question a bit in the chat. Specifically, he wrote that if the edge of the network goes offline, can devices within the edge still transmit data, authenticate, communicate? And I think you answered some of those concerns. Now, I suppose one possible strategy would be in your edge node to have several types of connectivity built in, right? If you want to mitigate the potential loss of the network.
Yeah, but you actually don't need to do that at all. What we've done is build a software overlay network that sits on top of any connectivity. And so you can process that data locally and, process it in offline mode as well. And at some point, there's going to be some connectivity to it, right? Whether it be Bluetooth, low power wireless, cellular, satellite, it doesn't matter, Wi-Fi. And at that point, you can store and forward the messages and push it back to where it needs to go. So now you can rely on instances where connectivity is not an issue, and oftentimes people want to run edge computing in poor or low quality environments where connectivity is quite limited.
All right. We have another question from Glenn asking, getting started, what would you recommend as a good starting point to developing for a proof of concept edge device? Open source sample project for Raspberry Pi, for example, or so? Well,
I'm obviously going to be biased, so I would actually direct you to Eclipse IOFOG because what you can do is there's a one-line install for developers to install a environment on their local laptop, which enables them to simulate an edge environment. You get 3 nodes that are kind of a simulation where microservice is already running, and then you can deploy your own microservices from a Docker Hub, a repo, and start with code that you already have, or you can write specific code, and then you can then push that to the device itself. So oftentimes, developers want to start on their local machines and push it to the device and deploy it, and we enable you to do that. So I would say that's a good place to get started. And our engine is available for free, the complete and open source version at iofog.org, which is under the Eclipse Foundation.
And that makes sense. So I suppose as you start building the software to virtualize the devices and focus on the value you are delivering. But let's say you are new to this and you want to build a proof of concept device, that will, once the software is ready, that you want to experiment with in order to determine what kind of sensors should I actually buy, what kind of board should I actually buy. So what would you recommend for people to play with first?
I think the Raspberry Pi is a great starting point. Also, coming out shortly is the Jetson Nano. So if you're doing stuff that requires more compute, right now we realize people want to do deployments on devices as well. So there's going to be short order videos to get started using, like, creating an edge compute network using Raspberry Pis, and then shortly thereafter on the Jetson boards, because we often see those two are being used the most. If you're starting on POCs or if you're an in-home kind of person, people are often using Raspberry Pi devices to get started. If you're doing something more enterprise heavy, people are starting to use things that are more compute intensive, like the Jetson.
Okay, that makes sense. Thank you very much. All right. So it seems we are out of questions for the time being. So what we can do now, I will just briefly share with you all, since we have the time, early insights about our developer survey. And then if there are additional questions, write them down while I'm talking about those survey insights, and we'll ask them to Farah before we end the call. All right, so let me share my screen. And this time I hope my browser won't crash. All right, it worked. All right. So developer survey. So every year, Eclipse IoT has been running a developer survey. And typically participation has been good, but this year participation has been really exceptional. I mean, we've got 3 times the number of responses compared to last year, and 2 times the number of complete responses. So, people who took the time to answer the 20 plus questions that we had. And it's really, really exciting. We had a variety of collectors. I mean, the Eclipse website had one, but lots of our community members participated in order to send people to our survey. And Bosch, the IoT working group, this virtual meetup, and CirrusLink have been the most active. So thank you everyone for participating, and thank you everyone for getting the word out and getting people to fill the survey. So we are still working on the analysis and on a fancy slide deck to present the insights. So my slides are very bare, but this gives you an early taste of what we found. The first one is, it's really interesting. 2/3 of the respondents to our survey said that their organization is working on IoT stuff right now, or will do so in the next 18 months. So IoT really has momentum behind it. And when I say IoT, I include Edge here, really. It's IoT, Edge, and even cloud analytics. Really, the 3 of them are really, really, really having momentum. The top 3 concerns for developers, and they are the same as last year in our survey. So that's in order: security, connectivity, data collection, and analytics. But connectivity overtook data collection and analytics in the number 2 slot for this year. And to me, this shows that, well, there are many emerging standards in mesh networking, field networking, stuff like that. And sometimes they are not compatible, so connectivity is becoming a growing concern. But using, could we say, Farah, that using the right toolkit, you can abstract a bit those connectivity problems and focus more on the application?
Absolutely, and that's what developers should be doing. Anytime you make them think about anything other than writing software, it's not a good day for us.
All right, makes sense. Top project verticals. So there's no change in the top 3. I mean, building IoT platforms, home automation, industrial automation, and excuse me. I mean, what the examples you showed, Farah, are from the 3rd category. So obviously, this is very, very relevant. You talked also, Farah, about automotive. In my case, when I was in a previous job, building automation was a big thing. So roughly speaking, this is where the market is at. Education, it seems, has been a big surge. So if we try to apply the edge computing concept at education, Farah, what could we do with your tools in an education context? Farah?
Sorry. In the context,
sorry.
Yeah, sorry. I was chatting with myself on mute. I was having a great time. So in the context of education, we're seeing a lot of data being, provided in schools that were, enhanced learning environments. And so, the ability to learn in a different way, with videos, with, in virtual reality environments where people actually get to have a chance to experience the things they're learning, actually touch it, right? Like, running compute at the edge enables us to serve up that data in an easier way that would enable learning for the kids.
And that certainly makes sense. Thank you. And it seems fintech also gained a few ranks in our survey. So obviously, with fintech, banking, financial, blockchain, distributed ledgers are never far away. So there is our connection to blockchain there. Also, in our early insights, we found out that Eclipse IoT has been identified by our respondents as the most influential IoT organization ahead of the Apache Software Foundation and Linux Foundations. So yay for us. Thank you all for this proof of your confidence. And 45% of our respondents use the Eclipse desktop IDE, and close to 10% also use Eclipse Shea. So this is our cloud IDE that you will run in the browser. So a massive momentum for Eclipse development tools there. So once again, thank you very much. Still strong showings by Visual Studio Code, one of my personal favorites, and Notepad++ as development tools. So this is, not really surprising. Anyway, so those are early insights. So please stay tuned for the full slide deck that we will release somewhere in April with our full findings. And let me see now in the chat. So we've got an additional question from Satish Rao. Any challenges you faced powering edge devices in remote areas? You are probably still...
Yeah, I'm still great. Still low and on mute. Those are good questions, Satish. Edge software actually needs a way to understand the power of the edge compute node. IoFog actually provides a set of control signals so the edge software can prepare itself. We have a low power mode that allows edge microservices to know they should prepare for a possible power down. And solar battery charging is common for remote areas, but the sun isn't always shining. So that's all things that we actually have, to really think about when we're running software at the edge. So we do have that ability to kind of manage power or manage software to run in different modes depending on the type of power that is available. And that's definitely something we have to think about.
Yeah, and probably then, when you think about it, obviously, if you have a use case where you need devices in remote areas, obviously picking low power hardware, low power connectivity is useful, and also monitoring closely the power of those devices. So there are other projects in the Eclipse IoT ecosystem that are targeted at that, and specifically Eclipse Voltron. Maybe using both IoFog and Voltron together in that kind of context to get more detailed power profiling of the devices could be something interesting.
And Satish, I noticed you've asked a ton of great questions, and I would highly encourage you to reach out after the talk so we can take this offline. And obviously, please ask more questions, but so we can dig in deeper into your questions, and you could talk to people who are more technical than I with regards to some of your technical questions.
Indeed, excellent. No more questions left. So I think, Farah, the only thing left is really thank you so much for being with us, for being with us this morning or this afternoon and evening all over the world. So people can look forward to see you in person at our upcoming IoT Day. And I'm personally looking forward to that since we didn't have the opportunity to meet in person yet. So that will be certainly good.
I'm looking forward to it as well. And, I'm obviously in a unique position, because of my involvement with Edgeworx, that we're getting to see some real world use cases spring up all the time. So if you've heard this talk once, there's obviously going to be new content moving forward in terms of different use cases that would be popping up. And so highly encourage you to come by to the Eclipse IoT Day and hear more.
Excellent. And don't forget, for those in Europe that cannot make the trip to California, there's still a Bosch Connected World at the same time as well. Now, this is the end for this broadcast. Thank you very much. Thank you for putting with us and our little technical troubles at the start. We really appreciate you stuck with us till the end. So, I hope to see you at our next broadcast. And in the meantime, don't hesitate to reach out over Twitter or through the mailing lists for our Eclipse IoT community. So thank you for joining us today, and see you next time.